This video is to discuss two standards, F1 and F5, understanding the concept of a function, and then also looking at function notation. How do we use function notation? How do we evaluate function notation? Review of what is a function. You talked about this last year, and you learned that a relation is anytime we pair an input and an output. And these pairings can be represented as a mapping diagram, a table, a graph, an equation. All of those are ways to show a relation. So every time you look at a table, a graph, an equation, or a mapping diagram, you're looking at a relation, some relation between the inputs X and the outputs Y. The goal here is for you to understand, when is a relation a function? So a common question is this a function? Well, the definition of function is any relation in which each input, so each X, has exactly one output. X cannot repeat with a different Y. Each X can only be paired with one Y. Y can repeat. So, for example, the input 2 could be paired with the output 5, and the input 3 could be paired with the output 5. And if those 2 points are part of the relation, that's okay. It would still be a function. In fact, that would be a horizontal line. A horizontal line is a function. If X repeats with a different Y, it is not a function. If X is 2 and Y is 3, and X is 2 and Y is 4, that is not a function. And that would be a vertical line. Vertical lines are the only lines that are not functions. We're also going to be talking about domain and range. Domain is the set of all X values. Range is the set of all Y values. And we're going to discuss the difference between discrete and continuous. Discrete are points only. Not all X values make sense. So we use points only to represent discrete data. We connect the points to create a line or a curve, and that is continuous data. We're going to look at discrete data would be a list of the values, the X values and the Y values, just a list, always from least to greatest. And then if it's continuous data, we would use interval notation to describe from here to here and everything in between. Remember, with interval notation, a parentheses means that it's not included. You always use a parentheses around infinity and negative infinity. A bracket would indicate that it's included. So in this example, all of the values would be from 1 to 7, including 1 and including 7. If you wrote it from 1 to 7 this way, you would not include 1, but you would include 7, which means there's no ordered pair with a value of 1, but there's ordered pairs with everything above 1. Function notation, we use f of x instead of y when we talk about function notation. It doesn't have to be f, but that's very common because it's just saying f of x, a function of x. This is not representing multiplication. This is just how you represent the y value. So whenever you look at f of x, that is what we use in place of y. So instead of y equals mx plus b, it would be f of x equals mx plus b. It could be f, it could be d, it could be c, it could be t, it could be c. Any of the variables could change. For example, a very common one would be d of t, because we know d represents distance, t represents time, and distance is a function of time. Let's look at some examples. This is a mapping diagram. Is the relation a function is the first question. So you're going to look at the inputs. The inputs are the x values on the left. The outputs are the y values on the right. -3 is an x value paired with only one y value. 4 is an x value paired with only one y value. However, 1 is an x value paired with two different y values. So no, it is not a function because the x value 1 is paired with more than one y value. Remember, a function, each x has exactly one y. This is discrete data because these are points only. The points are -3, 3, 1, -2, 1, 4, 4, 1. Those are 4 points, 4 distinct points. So we would just list the domain from least to greatest. The domain are the inputs, -3, 1, and 4, the x values. The range are the outputs, and least to greatest, it would be -2, 1, 3, and 4. F of 1 means when x is 1, what is y? Well, when we look up here and we have an x value of 1, the y values are -2 and 4. When x is 1. However, when f of x is 1, another way to say that is when y is 1. So when is y 1? Look at the y column. When is y 1? When the x value is 4. So f of 4 is 1. So the x value is 4 when the y value is 1. Use the graph below to answer the questions. Is the relation a function? So remember we said that a vertical line is not a function because a vertical line is in the format x equals a number. So for example, if we said x equals 0, I could draw the vertical line x equals 0. And how many points on that line are on this curve that we're looking at? Only one. Any other vertical line I draw, if I draw x equals 4, do we see more than one point on that vertical line? No. The only ordered pair would be 4, approximately -8. So are there any ordered pairs that are on the same vertical line? No. So that means, yes, this is a function because each of these inputs, each time I move on the x-axis, there is only one y value that goes with each x value. Each x value only goes to one place. This is continuous data, which means there should be arrows here. This is continuous data because the points are connected to form a line or a curve. And the domain, since we are saying there are arrows here, that means that as I move left and right on the x-axis, every x or y value would have an associated y value. Every x value has an associated y value. So the domain is all real numbers, which would be written -infinity to +infinity. Whereas when we look at the range, are there y values associated with 10? Yes. There are 2 points that have a y value of 10. Are there y values associated? When we go up and down on the y-axis, do all the points have a y value? Oh, wait, no. There's a minimum y value right here. We're just going to approximate that and say that the lowest y value is -8. It's really some value above -8, so we could say -8 is not included. Sorry. -8 is not included, so I used a parentheses. If that point was right on -8, I would use a bracket. So -8 all the way to +infinity is my range. Why? Because there aren't any y values, there aren't any points down here below the -8. So there's no ordered pair that has a y value less than -8. f of 1. F of 1 means you're plugging in 1 for x. So where is 1 on the x-axis? Right here. So what point is associated with f of 1? F of 1 has a y value of 3. If f of x equals 1, so we said f of x is kind of like y, if y equals 1, so go to 1 on the y-axis and look at all the points that have a y value of 1. So what are all the x values of those points that have a y value of 1? It looks like we have -6, -2, +2, and +6. So all of these x values have a y value of 1. Okay, let's keep going. Is this a relation, a function? So we want to see if each x value is paired with only one y value. -6 is paired with 8. -4 is paired with -9. -2 is paired with 3. 1 is paired with 6. 5 is paired with 3. And 8 is paired with 6 and 0. This x value 8 is paired with 2 different y values. No, this is not a function. 8 cannot be paired with 6 and another point that has an 8 and a 0. This is discrete because we have distinct points that are not connected. The domain, since it's discrete data, we would just list all the x values. So the x value of this ordered pair is -6. I'm going from left to right because we want to go from least to greatest. The x value of this ordered pair is -4. The x value here, -2, 1, 5, and 8. No repetition, so we'll just list 8 once. The range, we were going to go from least to greatest. The range is the y-axis, so whenever you're looking at the range, you're looking at what is the associated y value. Let's go from least to greatest, so the lowest point has a y value of -9, so -9. There's no other points until we get to a y value of 0. Then we move up and we have a y value of, both of these points have a y value of 3. Again, there's no repetition when you list the domain and range. Then we move up and both of these points have a y value of 6. And then the highest point has a y value of 8. So that is our range. F of 8, so f of x when x is 8. When x is 8, we have 2 y values. 0 and 6 are our 2 y values when x is 8. When y is 8, so again f of x is like saying y. When y is 8, so go to 8 on the y-axis, what is the associated x value? -6. Okay, so that is function or not, discrete or continuous, domain and range. We're going to continue with evaluating functions and function notation in the video part 2.